This is a key to the worksheet on properties of exponents. And so in each of these problems, you want to simplify each expression. So let's go ahead and look at number one. So number one, we have this expression that's being raised to the fifth power. So we have x cubed times y to the fourth raised to the fifth. Now when doing this problem, you're going to think about these properties that you've learned. So one of the properties that you learned is power of a product rule. So the power of a product. So the power of product rule says that I can take each of these factors that's in this parentheses here and raise it to that fifth power. So basically I'm saying x to the third raised to the fifth times y to the fourth raised to the fifth. So it'll look like this. It'll be x to the third raised to the fifth times y to the fourth raised to the fifth. And in your mind, that's what you're thinking. So most students can go from here to the answer without having to write this down. In their mind, though, mentally, that's what you're thinking. You're saying you have this power of a product, and so according to the power of a product, I'm going to take each of these products here, and I'm going to raise it to the fifth power. Now at this point, notice that you're going to use the power rule at this point. So when you have a power raised to power, you multiply those exponents. So this becomes x to the 3 times 5 is 15, and then y to the 4 times 5 is 20. And that will be your answer. All right, so the answer number one is x to the 15th, y to the 20th. So x to the 15th, y to the 20th. All right. Okay, so the same idea number two. So if you look at number two, and I'll put number two here, we have 3x y to the fifth raised to the second power. So again, I'm using the power of a product rule. So notice I'm saying power of a product rule, power of a product. And so you have this product in here, 3 times x times y to the fifth, and that's being raised to a power, to an exponent. So according to the power of product, I can take each of these products right here, each of those factors, and raise it to that power. So this becomes 3 squared times x in parentheses squared times y to the fifth squared. All right. And then here, I know that 3 squared means 3 times 3, so that's 9, right? And then x squared means x times x, so that's x squared. And over here, I'm going to use the power rule. So y to the fifth times itself twice is the same thing as saying 5 times 2 is 10, so that's y to the 10th. So you have y to the 10th. So that's the answer to number 2. So number 2, we have 9 x squared y to the 10th. So again, most students, if not all students, can go from here to this. Mentally, though, this is what you're thinking. All right, so number 2. And number 3, we have negative 2x squared y raised to the third. So it looks very similar to number 2, except you got to be careful when you have that negative inside the parentheses, especially if it's being raised to an even power. Because if you're not careful, you may, if this is an even power, you may get the wrong answer. So just be careful. So again, using the power of a product, I have negative 2 raised to the third power. So I'm going to take each of those factors here, each of those products, and raise it to the third power. So negative 2 to the third times x squared to the third times y to the third. Now, negative 2 to the third, remember means negative 2. Negative 2 to the third means negative 2 times negative 2 times negative 2, right? So negative 2 times negative 2 is 4, and then 4 times negative 2 is a negative 8. All right, so that's negative 8. And then x squared cubed, so here I'm using the power rule. So I'm using the word power rule, right? Power rule. So the power rule will, when you have a power raised to power, you multiply exponents. So 2 times 3 is 6, get x to the 6. And then y to the third is just y to the third. Because remember, this right here is understood to be 1, right? So I can still use the power rule here. 1 times 3 is 3. All right, so that is the answer to number 3. Number 3, we have negative 8, x to the 6, y to the third. Okay, now number 4, let's take a look at number 4. So number 4, we have this rational expression, or this fraction, 1 divided by 3 x squared y to the fifth, and all that's being raised to the third power. So here, remember when we talked about this? We talked about this in terms of power of a product. So this would be power of a quotient. So power of a quotient rule. So I have a quotient this time, right? All right, so according to the power of a quotient, I take the numerator, raise it at power, and take the denominator, raise it at power. So this is what it looks like. It'll be 1 raised to the third, and then the denominator, which is 3x squared, y to the fifth, raised to the third as well. All right, so the power of a quotient rule. That's what I'm using here. Then we know, simplifying this a little bit further, here's what we get. We know that 1 raised to any power is always 1, right? Okay, now let's talk about this right here. So this, if I cover this part up, so let me kind of show you. If I cover this part up here, the numerator, that looks like this right here, right? So now I'm going to use the power of a product. So the power of a product rule says, for the denominator, says I can rewrite this as 3 cubed times x squared cubed times y to the fifth cubed. Okay? Now, in your mind, that's what you're thinking. Most students can go from here to the answer without having to write it down, but in your mind, you are thinking this. All right, now let's talk about the denominator a little bit further. 3 cubed means 3 times 3 times 3, so that's 27. X squared, so we're using a power rule here. 2 times 3 is 6. You get x to the 6. And same thing here, power rule. 5 times 3 is 15. All right, so that's the answer. 1 divided by 27, x to the 6, y to the 15. Okay, so 1 divided by 27, x to the 6, x to the 6, and then y to the 15. Okay, so remember what we did. So we used the power quotient here. That's how we got this. So to go from here to here, we use the power quotient. Then what we did here, notice what we did here was we used the power of a product rule, right? And then at this point, I just used the power rule here. And then we knew that 3 cubed means 3 times 3 times 3, which is 27. Okay, so that was number 4. All right, let's look at number 5. Number 5, and we can write that here. Number 5 looks like this. We have same thing. We have a quotient. So we have 3x to the fourth divided by y cubed raised to the second power. So according to the power of a quotient, I can use a power of a quotient here. So that means I take the numerator, 3x to the fourth, raise to the second power. I take the denominator, y cubed, raise to the second power. So that's the power of a quotient. Then I'm going to use the power of a product here in the numerator. So according to the power of a product, I can rewrite the numerator as 3 squared times x to the fourth squared. All right, so I'm squaring each of these. See that? Then at this point, I'm going to go ahead and just use the power rule here. So y to the third power squared is y to the sixth. And then I can rewrite this now as 3 squared means 3 times 3, which is 9. X to the fourth squared, using a power rule, 4 times 2 is 8, so I get x to the eighth, and then divided by y to the sixth. All right, very simple, right? Not difficult at all. A very simple process. It's just being able to use your properties. So this is 9x to the eighth divided by y to the sixth. Okay, now number 6. So let's look at number 6. So in number 6, we have this situation. All right, so here's number 6. We have, in the numerator, we have y cubed times y squared to the fourth divided by y cubed squared. All right, now you need to be a little bit careful with this one. So don't make the mistake. It is a mistake to do this. Just say y cubed times y squared is y to the, remember you multiply base to add exponents, but you cannot do that here. So that is a mistake to say that's y to the fifth. Okay? And the reason is because this y squared is being raised to the fourth power. So you have to deal with exponents first. So remember the order of operations, exponents before you multiply. All right, so always remember that. So I've got to deal with the exponents first, and then I can multiply. See, this is multiplication right here, y cubed times. But this is being raised to the fourth power, so I've got to do this first before I multiply. All right, so keep that in mind. So the first thing I'm going to do is, I'm going to put that horizontally here. First thing I'm going to do is use the power rule. So I get y cubed times, now remember, y squared raised to the fourth, you're going to multiply those exponents, so that'll be 2 times 4 is 8. So that'll be y to the 8th. And do the same thing here, power rule, power rule. 5 cubed squared, 3 times 2 is 6. All right? Okay, so remember what I did was I used the power rule, right? So I used the power rule. Okay, now I can multiply like bases. So I can use the product rule for exponents here. So the product rule for exponents says that when you multiply like bases, you add exponents. So it'll become y to the 3 plus 8 is 11 divided by y to the 6. All right. Now I'm going to use the quotient rule for exponents. Remember, quotient rule for exponents says when you divide like bases, you subtract exponents, right? The exponent of the numerator minus the exponent of the denominator. And so the answer then is y to the, and then 11 minus 6, what's that? That's 5. So you get y to the 5th. All right, so that's the answer to number 6, y to the 5th. But that's the process you have to go through. Okay, so you have to go through this process. You had to raise this to the fourth power first because order of operations says I do exponents before I multiply. All right, okay. All right, so I use a power rule, and then to go from here to here, to go from here to here, I guess right here, you notice that I use a product rule, right? Product rule. And then to go from here to here, I use the quotient rule. So just remember all these different rules that we learned. All right, so knowing those rules helps you in all these problems. Okay, number 7, we have x cubed to the 4th times x squared to the 3rd. All right, so it's the same idea. The discussion or the ideas, the concepts is the same as in the previous problem. You cannot. So if I cover these exponents, these outer exponents, you cannot multiply these first. You cannot say that's x to the 5th. And the reason is because this x cubed is being raised to the 4th first, and then this x squared is being raised to the 3rd first. All right, so the first thing you have to do is use the power rule first. Okay, so you have to use the power rule first. So x cubed to the 4th means x to the 12th. 4 times 3 is 12. Times x squared cubed, 2 times 3 is 6. That's x to the 6. Now we can use the product rule. So the product rule for exponents says when you multiply like bases, you add exponents. So the answer here will be x to the 18th power. 12 plus 6 is 18. All right, so that's number 7. So x to the 18th. All right, and then number 8. Okay, so number 8, we have a quotient. We have x squared y to the 4th z divided by 3x y squared, all being raised to the 3rd power. All right, so that looks a little bit complicated, right? It's not. Just think about all the stuff you've learned. So notice I have the power of a quotient. So let's deal with that first, this power of a quotient. So I can rewrite this as the numerator, x squared y to the 4th z to the 1st power, raised to the 3rd power, and the denominator, same thing. The denominator, 3x y squared raised to the 3rd. All right, so power of a quotient. Then I'm going to use the power of a product in both cases here, both numerator and denominator. So that becomes, in the numerator, I'm going to cube each of these factors here. So I get x squared cubed, y to the 4th cubed, and then z cubed. So I put all those in parentheses. That's important. The same thing in the denominator. 3 cubed, x cubed, y squared cubed. And I'm going to simplify each of those products. So x squared cubed, using the power rule, that's x to the 6. Y to the 4th raised to the 3rd power, 4 times 3 is 12, so that's y to the 12th. And then z to the 1st cubed, so that'll be z to the 3rd power. All divided by 3 cubed. 3 times 3 times 3 is 27. x to the first cubed is x cubed. Y to the second power cubed, 2 times 3 is 6, so that's y to the 6. All right, so that's where I'm at, okay? All right, now what you got to notice, though, is that I can simplify this further because notice I'm dividing like bases here. I have x's in both numerator and denominator, and I have y's in both numerator and denominator. But I don't have z's in the denominator, so I cannot simplify any z's, but I can simplify the x's. So you got to be careful how you do that. So what some students do in their mind is they think this. So mentally they think of it this way. They're going to rewrite this in separate fractions. And you can and sometimes it's easier to understand it that way. So this coefficient in the numerator right here, that's a 1, right? So I'm going to rewrite this as 1 divided by 27 times, now let's put the x's together. X to the 6 divided by x cubed, right? X to the 6 divided by x cubed times, let's put the y's together. Y to the 12 divided by y to the 6. Y to the 12 divided by y to the 6. And then z cubed, and then times z cubed. If you want to, put that over 1. Okay? Now, let's simplify. The only thing we can simplify here is this and this, using the quotient rule. So I get 1 divided by 27 times x to the 6 divided by x to the third power is x to the 6 minus 3. Y'all agree? Divide like bases, subtract exponents. Same thing here. Y to the 12th divided by y to the 6 is y to the 12 minus 6, and then times z to the third. All right? And if you want to at this point, you can put all this over 1. Now let's simplify each of these two right here. So I get 1 divided by 27 times x to the third power, 6 minus 3 is 3. 12 minus 6 is 6, times y to the 6, times z to the third. And then what I would do at this point, what you should do at this point, is write this as one fraction. So 1 times x to the third times y to the 6 times z cubed is x to the third, y to the 6, z cubed, divided by, and then 27 times 1, all these ones here is just 27. And there's your answer. Okay? So you have so the answer is in the numerator you have x cubed, y to the 6, z to the third power, divided by 27. Okay? Now, some students may write it like this. So you remember where we had that 1 divided by 27 right here? So you could say 1 divided by 27, x cubed, y to the 6, z to the third power. So either one of those is fine. Okay? Either one of those is fine. All right, just make sure you understood where that 1 divided by 27 came from, and that 1 in the numerator came from the fact that this coefficient right here is 1, so 1 divided by 27. All right, so that is the key to this worksheet.